The purpose of this experiment was to find out the velocity needed to pop a balloon with a dart. The original plan was to throw the dart, but that was way too complicated to calculate. Instead, we dropped a dart from directly above a balloon at a specific height. We measured out and marked a meter on a piece of tape. Then we hung a piece of string to ensure we were dropping directly vertical above the target. Taping the balloon down to keep it from moving when the dart hit it was definitely the biggest challenge. In the end, we worked out a pretty good method that involved taping the tie down and the middle of the balloon directly onto the X. The idea was that if the dart was dropped from too low, the balloon wouldn't pop, but if we were at the right height, it would. We popped a total of 10 balloons, starting at 40 centimeters and moving up 1 centimeter for every drop until the balloon popped. Although all the balloons popped at different heights, they were all within a 10 centimeter range. The more balloons we popped, the height required to pop them became lower. This random error is due to us refining our dropping and taping techniques. Eventually, we collected enough data to get a realistic average height to use in the calculations to find the necessary velocity. Now that I had all the heights tested and recorded, I had to calculate the velocity. I did this by using the law of conservation of energy, where EI equals EF. In this situation, EI was the initial potential energy, and EF was the final kinetic energy. This formula allowed me to use the acceleration due to gravity and the height that the dart was dropped at to find the speed of the dart when it hit the balloon. I found the speed for each data point using this formula, and then found the average speed of a dart needed to pop a balloon. This magic number is 2.96 meters per second. There were many sources of error in this lab, including whether the balloon was taped properly or even if our measurements were correct. We were able, however, to find a solid average, and I am confident the results reflect the truth.